Good day, ladies and gentlemen. Today we are going to work on two lessons, 4-6, estimating square roots, and 4-7, the real numbers. We're combining them because I don't think there's a whole lot of information that I need to present to you or a whole lot of work that you're going to need to do on your assignments. So we'll get through both of these. You can combine them on your Explain Everythings into one video. If you can somehow put them both in your video, that'd be great. Otherwise, if you could just get one of the skills in your video, either estimating the square root skill or something about real numbers, that would be wonderful, but your choice. So again, either combine if you can, or just do one or the other. Number one, it says name the integers that each square root is between. So we have the square root of 55. Best way of figuring this out is to determine what is a perfect square between the square root of 55 are two perfect squares that are around the square root of 55. So I know that the square root of 49 and the square root of 64 are between 7 squared and 8 squared. So we're looking for an integer that each square root is between. So the square root of 55 is somewhere between 7 and 8 because I know that 7 squared is 49 and 8 squared is 64. So my final answer for a problem like this would be, again, that brings me back to 7. This brings me back to 8. So I know my final answer for the square root of 55 is going to fall somewhere between 7 and 8. If that makes sense. I don't know if I did a great job of explaining that. But that's the process that you would go through to determine the integer that the square root, or the integers that the square root is between. So your final answer would be 7 and 8. Letter B, we have a problem that says the square root of negative 90. So again, we have to figure out what two integers the square root of 90 would be between. I know that the square root of 81 and the square root of 100 bring me to 9 and bring me to 10. The square root of 90 is between the square root of 81 and 100. So we know that it is going to be somewhere between 9 and 10. The only thing is we have to be careful because there's a negative on the outside, so we're going to deal with that at the end. And we're going to say that the square root, or the negative square root of 90 is somewhere between the integers negative 9 and negative 10. That would be about it for estimating square roots and finding the integers that they're between. Hopefully that made sense to you. I'll box my final answers for both of them. And that's really the process that I use when going through and determining or estimating the integers that the square root of a non-perfect square would be between. Moving on to number 2, we're going to now move into estimating into the real numbers. So we have a whole bunch of definitions for you. A review definition number 2 would be rational numbers. A number written as a fraction or a decimal that terminates or repeats. Integer would be a whole number and its opposite. Irrational number is a decimal that does not, or decimals that do not terminate and do not repeat. An example of an irrational number is pi. Another example of an irrational number, which is something I'm guessing most of you do not know or do not know, would be all whole numbers that are not perfect squares. So if you take the square root of any whole number that is not a perfect square, you have yourself an irrational number because it will not terminate and it will not repeat. So for example, if we take 49 and square it, or take the square root of 49, we get 7. That is a rational number. If we take the square root of 50, since it is not a perfect square, 50 is not a perfect square, you are going to get a number 7 point something, and it will not terminate, will not repeat. Therefore, any whole number that is not a perfect square is going to be an irrational number because it will not repeat and it will not terminate. So something that I'm guessing most of you are not aware of. Letter C, be careful with calculators. They only show a certain number of digits. You may even see a pattern. So if you take the square root of 50 and you type that into your calculator, you are going to get something. I'm typing in right now. You are going to get a number that looks like it terminates, but it doesn't. Obviously, on your calculator, it shows an ending point, but because your calculator can only show a certain number of digits, you can't be certain that that number is terminating at the end of the last digit shown on your calculator. You may even think you see a pattern, but be aware, anything that is not a perfect square, and if you take the square root of it, it is an irrational. So you just got to be careful with calculators. Real numbers. The real numbers would be all rational and all irrational numbers would be considered real numbers. On the left side of our chart here, we have rational numbers. Includes whole numbers, and rational numbers include integers. The way this chart works is clever in the fact that a whole number actually is an integer. An integer is not necessarily a whole number though. And then an integer is definitely a rational number. And then irrational numbers, you already know the definition for irrational numbers, anything that does not terminate or repeat. So rational numbers and irrational numbers are all considered real numbers. A whole number is an integer and a rational number. An integer is a rational number but not necessarily a whole number. So that's a little bit of a tongue twister. If you pause the video and think about that for a little bit or rewind it, it should make sense based on the work we've been doing. Write all names that apply. So a major part of your assignment and a major part of the work that you're going to be doing would be writing what kind of numbers are. Are they real numbers, rational numbers, integers, whole numbers, irrational numbers, and so on. So we are going to take the square root of 9 and we are going to decide what it is. Is it a, back at our chart here, is it a real number? Is it a rational number, integer, whole number, so on and so forth? So if we look at the square root of 9 and we solve it, we know that the square root of 9 is 3. We know that 3 is rational. We know that 3 is an integer. We know that 3 is a whole number. And we know that 3 is then definitely, since it's all of those, a real number. So all 4 names apply to 3. Rational, integer, whole, and real. 3, or the square root of 9, which is 3, falls in this category. And when solving these, I would definitely take like the square root of 9, and I would definitely solve and use 3 as your answer, because the square root of 9 and 3 are the same thing. Negative 35 and 9/10. So we have to decide what is negative 35 and 9/10. We know that it terminates, so it's going to be rational. The definition of an integer would be a whole number. A definition of an integer, let's go back up here, would be a whole number and its opposite. It's not a whole number, so it is not an integer either. So no whole number, not integer. We know it's rational, and the only other thing that we can call this then would be real. Rational and real. Moving on to number 7, we have the square root of 81 over 3. That would be, the square root of 81 is 9 over 3, which equals 3, and it's going to be the same answer as you get for A. It's a rational, integer, whole, and real. D, the square root of 21, based upon what we told you earlier on in the notes, all whole numbers that are not perfect squares are classified as irrational numbers. So we are going to classify the square root of 21 as irrational. But since it's irrational, we're still going to consider it real, since irrational and irrational numbers are all real numbers. 0 over 3. 0 over 3, when you solve, that gives you 0. So 0 is simply going to be considered a rational. We don't consider it a whole number. We don't consider it an integer. We consider it just rational and therefore real. The square root of negative 4, you cannot take the square root of any negative number. So this would be our first example of a not real number. When you type in negative 4 on your calculator and hit the square root button, you are going to get the error message on your calculator. It would be a definite sign that it is not real. The square root of 23, again, very much similar to the square root of 21, since it's not a perfect square. It's going to be irrational because it will not end, it will not terminate, it will not repeat. Irrational numbers are real. 9 divided by 0 can't be done. You're going to get an error message in your calculator. Therefore, we're going to consider this not real. And number 7, the density property. This states that between any 2 real numbers is another real number. This would be true for rational numbers as well. Between any 2 rational numbers is another rational number. It's not true for whole numbers or integers. I have the whole numbers 1 and 2. There is no whole number between 1 and 2. And same thing for integers. If I have negative 1, if I have negative 1 and negative 2, there is nothing between negative 1 and negative 2 as far as an integer. Therefore, the density property does not apply to integers. It does not apply to whole numbers. It only applies to rational numbers. An example would be like number 8. Find a rational number between 3 and 2/5 and 3 and 3/5. Best advice I can give you for solving something like this would be to convert it into a improper fraction. So 3 and 2/5 converted into an improper, as you know how to do, would be 17/5. 3 and 3/5 converted into an improper would be 18/5. Okay, we have 17/5, we have 18/5. Not real easy to find something between 17/5 and 18/5. So now that we have that as an answer, I'm going to punch 17/5 into my calculator, or 17 divided by 5 into my calculator, and get 3.4. I'm going to punch 18 divided by 5 into my calculator and get 3.6. So I now know that a number between 3 and 2/5 and 3 and 3/5, since I can't really find anything using the approach of solving and getting a mixed number, I converted to decimals, and I have 3.4, 3.6. Something between the two of them would be 3 and 5/10, which would be ultimately your final answer. So you may have to utilize a couple of your strategies to find a real number between something like the example of number 8, in which you have mixed numbers that are really close to one another. If you can't find an improper fraction, go ahead and convert to decimals, and hopefully that will give you your final answer. Good luck on your work and assignment.